Hey guys, it's Mr. Bison here, and I'm going to be talking to you today about Edexcel's large data set, which is the one with all of the different weather stations. Now, I've got these kinds of videos taking you through particular topics. I've also got all of my playlists of videos where you can always comment on them. I try to reply to every comment, but if you're looking for any extra support, I do offer some ticketed events, and at the moment I've got some preparing for the exams, as well as an integration masterclass, and all the information is in the description. So I hope to see you in one of those, but now we'll just get on for looking at all of these weather stations for the large data set. Okay, I cannot believe I am finally making a video on the large data set. Without a doubt, this is the most boring part of A-level maths. I just think it's a complete waste of time, but it is still in the exam and people get quite stressed about it. So I wanted to dedicate a short little video to kind of telling you everything you need to know for the large data set. And I've put all of the questions that are on the large data set all in this same document that you've got here. So if you go to the description, you can download everything that I'll be using here, as well as actually the large data set itself and a bit of a summary that's on these slides that we've got here. So without further ado, we're going to talk about my least favorite part of A-level maths, and hopefully it will leave you feeling a little bit more confident with this area. So the large data set, and I'm only talking about Edexcel here, which is about the weather kind of stations that we have. Just wanted to point out some things to try and get you to feel a little bit less stressed about the large data set. So in AS papers, it has accounted for 6.7% of all of the stats marks that have been asked so far. And out of all of the marks, which includes the mechanics and pure, the large dataset questions have only accounted for 1.25%. Now, I haven't included questions that are things of just like finding averages or just doing other things to do with maths, even though they're in a large dataset question. I am talking about the actual marks where you have to have some knowledge of the large data set. Now in A2, it's only been 5.3% of all of the stats marks and only 0.9% of the overall A2 marks, and that's over the last 6 years that we've got. So what I'm going to try and do is I'm going to try and give you the best chance of being successful with these questions, and hopefully just some of the visuals I've got here will kind of stay in your mind. So one of the most important things is that we don't have data for the entire year. We only have data for May to October. And we have data from two different years, 1987 and 2015, so that it's possible for us to compare the same month in two different years. Now, this visualization that I've got here, I've got the top part, which is obviously winter. Winter is windier, wetter, darker, and colder. I've got this section here. I've put green for spring, but obviously we don't have March and April. And then the summer months are in red, where it's the opposite of winter, where in the UK it would be calmer, drier, brighter, hotter, and then we go to the autumn months that we have here for September and October. And so if we're ever asked anything about one of the months, one of the months where we think it's either windy or wetter or darker or colder, October's a good suggestion for that one. Now, I also want to point out, I'm going to tell you everything in this video that I've got that will help you with all of the questions that come up. So whatever I say in this video, if you've watched it, you should be able to answer all of the questions that come up. Okay, let's have a look at the UK stations. So there are 5 different UK stations that we need to know. And the thing they seem to be quite interested in asking about is their locations on the map from either north to south or south to north. So I've got them on the map here. And actually, the way I remember where they go is that they are in alphabetical order, apart from Herne and Heathrow, which are the wrong way round in terms of the alphabet. So from the most south, it goes Camborne, then Herne, then Heathrow, then Leeming, and then Leuchars, which is actually up in Scotland. And you can kind of got some common sense about some of these things that we've got. So Camborne and Leuchars, they are both on the coast. And just kind of think what it's like if you've been to the coast before. It's usually windier, right? If you're by the seaside, we know that it's usually windier in those locations. That's just something that's worth bearing in mind. If there's like a very windy place in the UK, it's worth suggesting that it's either Camborne or Leuchars. Now, the common sense box. I hope we've got common sense, but we might not have common sense, so we're going to spell these things out sort of loud and clear. Now, if the temperature increases, we're going to think about what might happen to these 3 different things. Well, if it's getting hotter, it kind of makes sense that the amount of sunshine is also going to be increases as well. So if the temperature increases, the amount of sunshine increases. And that probably is the other way around. The amount of sunshine means a higher temperature. Now, if the temperature is high, we would expect the amount of rainfall to be low. Because if you think about what it's like in the summer versus what it's like in October, warm days in the summer tend not to be rainy, whereas when you get to October and cooler temperatures, there tends to be more rain. Now, when it's a hot day, we tend to have lower wind speed. So as the temperature increases, the wind speed also decreases that we've got here. So just kind of go with your gut with these weather things and just think, what is the most common sense thing that might happen? Now, again, some common sense stuff. As we move further north on this map, I want to think about during May to October what might happen. Well, let's say it was just in one particular month. What happens to the temperature? If you have been on the south coast versus being up in Scotland in the summer, you will know that the summer in Scotland is a lot colder. So we're going to say that the temperature is likely, as you go north, it is likely to be decreasing. And that's obviously because you're getting further away from the equator. We know that it's rainier in the north as well. So the amount of rainfall as you go north is likely to be increasing. And the maximum hours of sunshine, I'm being very careful about this phrase that I've said here, the maximum hours of sunshine, you would expect in the north them actually to have a larger maximum number of hours of sunshine, because as you go further above the equator in the summer, the length of the days are longer. So the maximum hours of sunshine is also going to be something that would increase. But if we were talking about the average amount of sunshine, that's probably still going to be decreasing as we go north because of the fact that the weather tends to be rainier and not as warm. But I'm talking about the maximum hours of sunshine there. Now, this is where most of the stuff gets asked about in the exam. Most of the things are these parts that we've got. And I've taken the different measurements that are in the large data set and I've split them into two parts. I've done the section that is all about wind and then a section that is not about wind that we've got here. And I am going to just talk through this stuff because I think it's pretty useful to have a look at. So obviously, the daily mean temperature, I've put the word temperature in bold because if you ever answer a question, you don't have to say daily mean temperature. You can just say temperature and they would accept it. I mean, obviously it measures how hot it is, and the units are degrees Celsius for this. Now, the typical range that you might see for the UK is anywhere between sort of 5 and 24 degrees. Obviously, we're talking about May to October here. We know in the winter it would go much lower than 5. Now, the examples of what you might see in the large data set would be sort of a couple of data points like this, 12.0 degrees, 14.8 degrees. So you can clearly see here they've been rounded to one decimal place. Obviously, it's warmer in the summer. And we're only really looking at sort of the spring, summer, and the start of autumn. Now, the daily total rainfall is how much it rained in a day, and it's measured in millimeters. We can see it's measured in millimeters because this is actually a tool that you would use to do it. You literally see how much water goes in here, and you measure how far up it's gone in this tool. So that's why it's measured in millimeters. Now, the typical range is between 0 and 20 millimeters. You might see something that was higher than that if there was a lot of rain, but that seems to be what most of the data is. And you can also see that they're rounded to one decimal place because you've got 0 millimeters, 10.4 millimeters, and this TR, which I'm sure you know means trace, and I'll talk about that on the next slide. It's also really important that rainfall is not going to be a symmetrical distribution because there are many days where there are 0 or trace values. Trace values is basically where it didn't rain very much at all. Maybe it was just a tiny drizzle. And there's loads of days when it doesn't rain at all. So you don't get a symmetrical distribution. You get them kind of bunched to one end. Sunshine is how many hours of sunshine there was in a 24-hour period, measured in hours, and typically it's between 0 and 14 hours, but when we go up to Luchars in the summer, you do get some days where it's even more than 14 hours, because sunrise and sunset are quite far apart in the summer. Now you can also see these are rounded to one decimal place as well, so you might expect 3.3 hours or 10.4 hours. This was probably quite a cloudy day that we had, and then maybe this was like a nice clear day as well. Obviously, more sunshine in the summer months. Now, cloud cover is an interesting one. Cloud cover is how much of the sky is covered in clouds, and the units for this are octas. Now, octas sounds like what you'd expect it to, like it's got something to do with 8, okay? And that means because it can go from 0 to 8, and it can only take integer values here. Now, what they actually do to measure cloud cover is there's this grid, and this grid is split into like 8 different sections, and you literally like hold it up to like the whole section of the sky, and you see how many of those 8 sections are covered with clouds, and that's your measurement for cloud cover. So for the cloud cover, if we had 0, it would be a completely clear day, and if it was 8, it would mean that everywhere in the sky was covered in clouds. It's really important to note these are integers, and they basically measure what fraction of the sky is covered. Now, just because it's from 0 to 8, that doesn't mean there are 8 options. There actually are 9 because 0 is included. Humidity is how much water vapor is in the air. If it's above 95%, that's when that would usually be something like fog or mist. Doesn't mean it has to be fog or mist, but if there is a foggy day, the humidity level would be very high at like 95%. It's measured in percentage, and the typical range for the data that we have is around 70% up to full humidity of 100%. And again, they're kind of rounded to like integer percentages. So I've got these 3 as examples that I took from the table. Now, daily mean visibility is how far you can see. We don't need to know too much about the way that that's done, but it's basically just stood in one point, how far into the distance can you see a particular sized object. Now, this is the most annoying part of the large data set. It is the fact that the visibility is measured in decameters. I bet if you asked anyone what a decameter was, including maths teachers, we would be like, huh? We've got millimeters, meters, kilometers. A decameter is, I've even written it wrong on the table, which is how foolish I am. 1 decameter, I'll change it on the PDF, is 10 meters that we've got there. So a decameter is 10 meters. There's even another one, there's a decimeter. And I think a decimeter is like a 1/10 of a meter. So super confusing. We're just going to stick with decameters, which is with a capital D and an M. Now, daily mean visibility is typically between like the 200 to 4,000 decameters, which actually means the visibility is really 2,000 meters to 40,000 meters, or 2 kilometers to 40 kilometers. And in the table, these are some of the typical values. You'll notice they've been rounded to the nearest 100 for visibility. And the most important thing is they're measured in decameters. So I will change this in the PDF in the original one for when you download it. Now, the daily mean pressure is how much the atmosphere is pushing down. It's a bit complex to go into like what pressure actually does, but it's associated with different kinds of weathers. If they need you to know that kind of thing, it is mentioned in the question, and I will tell you that when we get to one of them that I'll do as an example. It's measured in HPA, which stands for hectopascals, and the typical range of things that you would see is around 1,000 hectopascals, from like 990 to 1,040. They're kind of like an average that we would expect is around 1,000. So a high pressure goes sort of above that average. 1,040 is a high pressure, 990 would be considered a low pressure. And again, you can see it's integers that we've got here because these don't have any sort of decimal values. They don't look like they've been rounded to the nearest 10 or the nearest 100. So I'd probably have a glance at this before I go in the exam. And I actually think this column that we have here is the most important one because it really helps us sort of visualize the data. If I just tell you this, well, and the last column, I actually think this part is the thing that makes you hopefully remember what some of these things might be. I wanted to talk a bit more about rainfall and the fact it's not symmetrical. I can't remember which one I took it for, but I took the data and I sort of made a quick graph for it. You can see along the bottom I've got these different groupings. You can see it's not a symmetrical distribution, so it would not be useful to do like a normal distribution for this because that distribution is clearly weighted at the bottom end that we've got there. It's got many values which are 0 or TR, which are the trace values. And I already showed you this. This is the tool of how it's measured, really, how you see how much rainfall there is. Now, the question talks to you about cleaning the data. Well, cleaning the data is to do with kind of making it something that we can actually put into a calculator and do some processing with. So if we see TR in a table, that means that there was a trace of water in the measuring instrument, just kind of like a tiny little bit of water. And it's used for values of rainfall where the rainfall is between 0 and 0.05 millimeters. So very, very tiny amounts. Now we can clean that data, which means replacing the trace with either 0 or 0.025. They will accept either of them. You can either just replace all of the traces with 0, or you can replace it with the midpoint, which is 0.025. But they will accept you replacing it with either of these things. If we're going to clean data, if we ever have anything that says NA for like not available, well, we just can't use that data. We simply have to kind of remove that entry and it can't be a part of the sample that we'll be looking at. The next thing I wanted to talk about, which feels like a different kind of section, is all of the measurements to do with wind. Now, again, I've put the bits in bold that would need to be mentioned. The daily mean wind speed, so the average wind speed, how windy it is measured in knots, which is kn, and it's typically between 3 and 10 knots. It could go a little bit higher, and they are integers only that we have here. So I've got 4 and 11 as an example. Now these wind speeds can get converted by something called the Beaufort conversion. That means it goes from being numerical data to qualitative data, so from quantities to qualities. And the typical range that you would see is for light to moderate. Now the sort of scale that I've seen in the data that we have, the lowest wind is light, then moderate, then fresh, then strong. But most of the days are going to be light that we have for this data. So this is, I think, pretty much the only one that is qualitative in terms of measuring how strong or hot or pressured or whatever it is. This is really the only one that's qualitative. Now there's a slightly different measurement, which is the daily maximum gust. It's actually saying what was the strongest gust of wind that day. And because this one is talking about how windy it is on average, it's not surprising that the maximum gust is going to be bigger, because it might have been like a big gust of wind that day. So it can go usually from sort of 8 knots to 50 knots. Again, they're integers only, and I've got a couple of examples from the tables that I've taken. Now these are the most annoying ones, because the wind gust or direction, which could either apply for the daily mean wind speed, or it could apply to the maximum gust that we've got here, they can be given in two ways. They can either be given as a bearing, and hopefully remember from GCSE that we would start with our sort of 0 degrees at the top. Apart from they started with 360 degrees, and you kind of like work your way around like this. So I don't know, that might be like 110 degrees, something like that. The way they do it, though, they don't have a 0 degrees. They call it at the top 360 degrees. So don't have it from a 0. It just goes from 10 to 360. And I've got a couple of examples. We could have 240 or 70 degrees here. Yes, as a bearing, it should technically be 0, 7, 0. But I think in the table, they actually just do it as 70 degrees. I wonder if I can actually just have a look at that right now. I'll have a look at that in a bit and see if I need to change it in the PDF. Notice they only come up in multiples of 10, so they're not that detailed about where they're coming from. And I'm going to talk about this bit in just a second. Now, the other version, instead of as a bearing, is the cardinal directions. Now, the cardinal directions, cardinal is just really saying where it is on a compass. So we need to be able to understand some of these things, but perhaps not this last one, which I think is a little bit detailed. So we've got north, southwest, and east, northeast. North, pretty obvious. Southwest is going to be between south and west. East, northeast is a strange one. So if I have north and I have east, and then here is my northeast that I've got here. If I do east, northeast, that is actually in between these ones. It is to the east of northeast. If I was going to do this one that was at the top, that would be to the north of northeast. So you have those different ways of describing these parts. Now here is the most annoying thing, is that for the wind direction, it is describing which direction the wind is blowing from, not to. So if you felt like the wind was sort of if you felt the wind was blowing like this direction, actually we would be describing that the cardinal direction would be this one. Okay, we would actually be kind of doing it as the opposite. We're describing where is the wind coming from, not where does it feel like the wind is going. Okay, so those are the 5 British stations that we've got, the ones in the UK, and these different measurements that we have here. I hope that these tables will be something you can glance at before the exam to have a look at. Now, the international stations that we've got, there are only 3 of them, and they're pretty generous about saying which one you think it might be if you ever have to guess that. Jacksonville in Florida has hot summers. It has hurricanes in October, but actually the mean wind speed in our data set are still relatively low, so I don't really see there's much evidence of those hurricanes in October. Just mainly it's noted for their having some hot summers in Jacksonville, which is in America. Now, Beijing in China has hot, wet summers, and it has colder winters. So if there's any sort of data for an international station that looks very, very cold, and it's got hot summers and then cold, another cold day or cold month, that's likely to be something that's edging into sort of October time for Beijing. And then Perth is probably the most interesting one of the international stations, because it's in the southern hemisphere, the seasons are flipped. So we're looking at sort of the summer months. Well, in Perth, that's actually the winter months. So we'd be expecting sort of some of the data to be colder in Perth for that time. Now, the international measurements are the same as the ones in the UK, apart from not all of the things are being measured. So these are the only things that are being measured: temperature, rainfall, pressure, wind speed, and wind speed with its conversion. So we don't have anything like the direction, the number of hours of sunshine, all of that kind of stuff. Some things to note here is that all of them are pretty much warmer in the summer, apart from Perth, which gets colder in its summer because it's its winter. The total daily rainfall, Beijing is very rainy in the summer. So if you have a very rainy destination and it's one of the international stations, it's very likely to be Beijing. For some reason, the wind speed is now being rounded to 1 decimal place, whereas when we looked at wind speed here, they were integers only. So I don't know why the data has changed like that. I can't imagine that's something that we need to be paying too much attention to, but hey ho, maybe. Again, the Beaufort conversions, mostly light to moderate, but most of the days are light in all of the data that I've looked at. So that's the kind of qualitative data that we've got there. So that is everything with the large data set. I'm hoping that by having this summarized, and I'm hoping that these kind of tables that we've got here, we will be able to answer some of these questions. Now, I'm going to answer an AS question and I'm going to answer an A2 question. And then at the rest of this document, I've got all of the AS questions that mention the large data set. And as we go a little bit further on, we've got all of the A2 questions that mention the large data set. And you'll notice I've put a red box around the questions that actually ask about the large data set, because if they don't have the red box, you don't need any knowledge of the large data set to be able to answer it. So I'm going to just have a go at doing these couple of questions that have got a red box. And then, yeah, we'll see if you can do the rest of them yourself. So in this question, it says that Jerry is studying the visibility for Camborne using the large data set of June 1987. Okay, so it's summer, it's coastal. The table below contains 2 extracts from the large data set. It shows the daily maximum relative humidity and the daily mean visibility. And it says the units for daily mean visibility are deliberately omitted. Given that the daily mean visibility is given to the nearest 100, write down the range of distances in meters that corresponds to the recorded value 0 for the daily mean visibility. Now, this is super sneaky of them because they want it in meters, but we know that daily mean visibility is given in decameters, and we know that 1 decameter is equivalent to 10 meters. So for part A of this question that we have here, we are talking about something that is being rounded to the nearest 100. So 0 rounded to the nearest 100 is actually representing 0 to, what is it for visibility? The range of distances. It's actually representing everything between 0 and 50 decameters, but because they want the answer in meters, we're going to have to times that by 10. So it is anything between 0 meters to 500 meters, because we know that decameters to meters is timesing by 10. And then they do some other stuff in this question, but we don't actually need that for the last part of the question. It says that Jerry drew the following scatter diagram using the June 1987 data for Camborne from the large data set. Oh, but they forgot to label the x-axis. I hate questions like this. Why would they forget to label the x-axis? So stupid, they would remember. So using your knowledge of the large data set, suggest which variable the x-axis on the scatter diagram represents. Okay, well, it can't be wind speed Beaufort. The reason it can't be wind speed Beaufort is because it's a number, and wind speed Beaufort, we remember, is like a qualitative data. It was light or moderate. Now, the other thing that it can't be is, what's the other thing I was just going to say it can't be? It can't be wind speed. Now, the reason it can't be wind speed is because there's basically no wind at all. And if you look at what we did for wind speed, actually wind speed is, on this part, wind speed is usually between sort of 3 and 10, but actually, crucially, it is integers only that we have for this one. So it is not going to be wind speed because wind speed is integers that we have here. Now, this is not going to be temperature. It might have been temperature, but the reason it's not going to be temperature is because it's June and there's loads of days where it's like freezing. So it's not going to be temperature. So most of the data is between 0 and 12. I think this looks like a good case of it being the amount of sunshine. So we can actually just say the word sunshine, and that would be enough to kind of get this, but it should obviously be the total hours of sunshine per day. So I'm going to say it's the hours of sunshine per day. Let's see how they've answered these bits. So it is the hours of sunshine. Notice how you don't have to have the hours there. And there's the 0 to 500 meters. So here we've got like the different reasons why it can't be certain things. It can't be cloud cover because the values go bigger than 8. Also, none of them, they're not necessarily integers, so it couldn't be cloud cover. Can't be wind speed because the values aren't integers. Can't be temperature because it's unlikely to go down to 0 in June. Okay, and then this is the maddest question. But actually, if we know how wind speed is measured, it's not too crazy. So I'm not going to read through all this beginning part. We're just going to have a look at these pressure parts that we've got down here. We're going to read from this part onwards where Stav knows. Stav knows that in the UK, winds circulate in a clockwise direction about a region of high pressure and an anti-clockwise direction about a region of low pressure. The table gives the daily mean pressure for 3 locations from the large data set on the 26th of September 2015. Now, it says here that we've got the mean pressure for these locations, which I think, from what we know before, was quite high. But the reason that we know this is quite high is because we would found out in part B what the mean pressure was. Now, I think the mean pressure, if we'd done this from part B, would be the sum of y divided by the number of days, which is 30. So that is 214. Is that the right thing I'm looking at? Find the mean daily pressure for these 30 days. Oh, it's been coded. So I'll add on the 1,110 afterwards. So that's 214 divided by 30, which is 7.13. So that means for the x, it would be x bar is y bar plus 1,010. So it's 1,017 that we've got here. So actually, if you see that this was the daily mean pressure, you can see here that these pressures are even higher for this different date that we've got here on the 26th of September. So we also know it's a high pressure because remember I said to you that 1,000 was kind of like the middle that we would expect here. So it's definitely above that. So we've been told what these cardinal wind directions are, and they're either west, northeast, and east. And we have to assume that these 3 locations were under a single region of pressure, and using our knowledge of the large data set, place each of these cardinal wind directions in the correct location in the table. Give a reason for your answer. So this data that we've got here, these are all examples of high pressure, which means it is going to be a clockwise direction. So I'm going to say the pressures, this is my reason, the pressures are high. So wind is clockwise. Now that's one of the things they wanted us to test. Can we compare these to what we worked out earlier on? The second thing is now thinking about whether we know which one is north and south. So from south to north, they go in alphabetical order, but remember Heathrow and Herne are swapped. So from the south, it will go Herne. I'm going to just do this as a little diagram. So we have Herne, then we have Heathrow, and then we have Leuchars. Now we want the wind to be going in a clockwise direction like this. That means the wind in Leuchars is blowing like that. In Herne, it's blowing like that. And in Heathrow, we'll just kind of work out afterwards. Now, this looks like that Leuchars, the wind is blowing to the east, but that means it's blowing from the west. So for Leuchars, it will be west. Herne, it looks like it's blowing to the west, which means it's blowing from the east. So for Herne, it will be east. And then Heathrow, it must be the northeast one. It must be the other one that we've got. That means that it is blowing from the northeast like this. And you can see these arrows are creating that clockwise direction that we've got here. So I can say that Heathrow is northeast. So Heathrow is northeast. Herne is east. And Leuchars is west. I mean, that question is bonkers. Let's just double check we've got it right. So high pressure, so it's clockwise. Don't need to say this part here. The locations go Leuchars, Heathrow and Herne. They've done it from north to south. And so we've got northeast, east and west for that part that we've got. And there was that thing I calculated earlier on. The 1017 was the pressure. So this was quite obviously some high pressure that we've got there. I mean, crazy, right? But I just wanted to show you that you can do these kinds of questions. So you've got the rest of these ones have been asked from 2018 to 2022. Eventually I'll add in the 2023 questions when they can be published. So go and download this and hopefully it'll be useful for you. If you do want any extra revision classes with me, if you go to the link in the description, I've always got my box office where I'm running some extra sessions, especially into the build up of the exams, where there'll be stuff on pure and stats and mechanics. So if you're interested in joining any of those, go and check them out and hopefully I will see you in one of those soon. Thanks guys, bye.